All right, you guys, read through the notes that are above. But basically what it says is, if we're trying to find possible zeros for a polynomial, the constant or the number here without a variable, that's going to be our p. And the coefficient of the leading coefficient of the variable at the highest degree, so x cubed is the highest degree, this is going to be our q. Okay, so the possible zeros are all of the factors of p over all of the factors of q. So what does that mean? So let's find the factors of 6. So the factors of p are 1 and 6 and 2 and 3. But each of these could be positive or negative, right? Because if we have a negative times a negative, we still get that positive 6. And then the factors of q, well, that's pretty easy. The factors of 1 are positive and negative 1. Okay, so if we have all of the factors of p over all of the factors of q, we basically have positive 1 over positive 1, negative 1 over positive 1, negative 1 over negative 1, and negative 1 over positive 1. Okay, so I'm not going to do them all out, but basically we have 1 and negative 1, right? Because 1 over 1 is going to be 1, negative 1 over negative 1 is going to be 1, negative 1 over positive 1 is going to be negative 1, and positive 1 over negative 1 is going to be negative 1. So all of those first ones are just basically positive and negative 1, right? So positive and negative 1 could be a possible zero, or positive 2 over positive 1. So it could be 2, positive or negative 2, positive or negative 3, and positive or negative 6. And the reason that is just because the denominator is 1, so it could be any of those. So those are all of the possible zeros, right? Positive or negative 1, positive negative 2, positive negative 3, and positive negative 6. Test a possible zero to see if it's a real zero, either using polynomial division or plugging it in as x. Well, let's just practice plugging this in, right? So let's practice negative 1. And with the negative, it is extremely important to have the exponent on the outside of the parentheses. So negative 1 instead of x cubed, right? Plus 6 times negative 1 parenthesis squared plus 11x plus 11 times negative 1. And it's really important that that negative is inside the parentheses for the calculator, plus 6. So, boom, it's almost like I knew it. Negative 1 is a real zero. Okay, so tested. Negative 1 is 0. Word. What that means is the factor, if negative 1 is a 0, the corresponding factor to negative 1, so the corresponding factor is x plus 1. Because if x is negative 1, if I add 1 to it, it's 0, right? So the actual factor is x plus 1 if the 0 is minus 1. And that kind of goes back to how we shift our function left and right, right? Once you find a 0, use polynomial division to find the quotient when it's divided. So then you're just going to have x plus 1, and then on the inside you're going to have that original polynomial. Okay? And do that division. But you guys can do it. You don't need me to do it. Oh, and then it says continue to do it until it's fully factored. So if you do it once, what do we have there? X cubed plus 6x squared plus 11x plus 6. X cubed plus 6x squared plus 11x plus 6. I'm going to pause this, do the division. Cool, so as you can see, with my division, x plus 1 is a factor, which I already knew. So remainder 0, so now I have x plus 1 times x squared plus 5x plus 6. Now, to continue factoring, I don't even have to do any more division. What I know is this is just a factorable quadratic. So all I need to do are find the two numbers that add up to be 5 and multiply together to be 6, and those are x plus 2 and x plus 3. So the rest of the zeros are, I have x1 is negative 1, x2 is negative 2, and x3 is negative 3. Now it's fully factored. Oh, and you write that there. Cool. Here are some more practices from the book it looks like they gave you, but I'm going to go ahead and stop here. But please have these uploaded for sure so I can give you points for them, and let me know if you have any other questions on the test before you finish it tomorrow.